Hello everyone. In this video, we are going to do few practice problem on functional group identification. These are few tricky functional groups. Those are confusing and students mostly do mistakes in identifying them. I would suggest you to watch my previous video on functional group where I have explained these tricky functional group in details. Link for that video is given in the description section. Now let's start with some of the problems. The first molecule is vanillin. In vanillin, there is a carbonyl group and the carbonyl group on both the side is attached to the carbon. So if I look at the linkage, is carbon, single bond, carbonyl and then carbon. This linkage is a ketone functional group. Next, there is oxygen, which is single bonded to carbon on both the side. So the linkage here is COC, making it an ether functional group. Then we have OH, which is directly attached to the benzene ring. And this is your phenol functional group. Next molecule is nicotine. In nicotine, we have a nitrogen in a ring. And this nitrogen is an amine, but the question is what type of amine, primary, secondary or tertiary. Now the nitrogen is attached to 3 carbon, so this is your tertiary amine. Here we have a ring which is a 6-membered ring, but one of the carbon of a benzene ring is replaced by nitrogen, so the name for this ring is pyridine. In this molecule, there is an OH group. So we have alcohol, but the carbon holding the OH is attached to 3 carbon. His first neighbors are 3 carbon. So this is an example of tertiary alcohol. Next we have carbonyl and sulfur together. We have learned that if there is a carbonyl and next to it is oxygen, then this is an ester functional group. But in this example, instead of oxygen, we are having sulfur. Sulfur is also known as thio. So the functional group here is thioester, carbonyl with sulfur. In this molecule, there is NH2, so it's an amine. But nitrogen of amine is directly attached to 1 carbon. Immediate neighbor is 1 carbon, so example of primary amine. We have carbon-carbon triple bond, that makes it an alkyne. We have oxygen, that is single bonded to carbon on both the side, and it's an ether. The next molecule is penicillin, and I'm sure that you're familiar with this molecule. Let's see what functional groups are present here. There is a carbonyl group, and next to the carbonyl group we have amine. So if in a molecule there is a carbonyl and amine together, then this functional group is a amide functional group. Here we have a benzene, but benzene is attached to the carbon, so the more appropriate name for this is phenyl. There is a sulfur which is single bonded to carbon on both the side. We have learned that if oxygen is single bonded with carbon on both the side is ether. So here we have sulfur single bonded to carbon on both the side, making it thioether. Again we have a carbonyl group, and this carbonyl group is next to nitrogen. That means it's an amide. But this amide is in cyclic form. As you can see, it is present inside a 4-membered ring. So the cyclic amides are also known as lactam. So we can say amide, but if we want to be more specific, then it's a lactam. Here we have a carbonyl group, and next to carbonyl group OH is present. So carbonyl group having OH attached to it is basically a carboxylic acid. So we have a carboxylic acid functional group, lactam, thioether, amide and phenyl ring. Next molecule is pyruvate, which is a very significant molecule in glycolysis. And if you look into the functional group, we have a carbonyl group, single bonded to carbon on both the sides. So this is your ketone. Another carbonyl group, but it is attached to OH. So this is your carboxylic acid. Alpha pyruvate is also known as alpha keto acid, because in this case at the alpha carbon, the carbon next to the carbonyl or the carboxylic group is alpha carbon, and this alpha carbon is having a ketone functional group. So he belongs to the category of alpha keto acid. In this example, we have a carbonyl group, and carbonyl group is next to oxygen single bonded. So if we have a carbonyl group and oxygen single bonded, then it's an ester. But if the same ester is present in a ring, then the name will be lactone. So here in this example, yes, it's an ester, but this ester is a part of this 6-membered ring. That's why it's an ester, but more specific if we want to be, then it's a lactone. So you have to remember that cyclic amides are lactam and cyclic esters are lactone. Here is a carbon-carbon double bond, so it's an alkene. In this molecule, we have CO2H. So if we open the structure, that means there is a carbonyl and there is OH together, so it's a carboxylic acid. Next we have OH. Carbon holding the OH is attached to 2 carbon, so it's an example of secondary alcohol. There is a carbon-carbon double bond, so we have alkene. Now let's see this functional group, which is having 2 carbon and 1 oxygen in a ring. If we look here carefully, then carbon single bonded to oxygen and single bonded to carbon. So the linkage is this. Yes, it's an ether, but this ether is present in a 3-membered ring with 2 carbon and 1 oxygen. So it's having its own specific name, and that is epoxide. Let's see this example where we have OH group, but the carbon holding the OH group is attached to how many carbon? 3 carbon. So yes, it's an alcohol, but it's a tertiary alcohol. Here we have a carbon-carbon triple bond, so it's an alkyne. And here NO2, so it's a nitrofunctional group. Benzene ring. And in the next example, we have many alkyl halides. As you can see that we have 4 alkyl halides and 1 carbon-carbon double bond. Carbon-carbon double bond is an alkene, and alkyl halides can be of 3 types: primary, secondary and tertiary. So let's find out. Carbon holding the chlorine is attached to the 3 carbon. So it's an example of tertiary alkyl halide. Carbon holding the Br is attached to 2 carbon. His first neighbors are 2 carbon. So it's an example of secondary alkyl halide. Similarly, the carbon holding the chlorine is attached to 2 carbon. So this is also an example of secondary alkyl halide. Now let's see the bromo group. Carbon holding the Br is attached to only 1 carbon. His first neighbor is 1 carbon. So this is an example of primary alkyl halide. The next molecule is having many rings fused together. So let's see what functional groups are present here. Oxygen single bonded to carbon on both sides is ether. Carbon-carbon double bond is alkene. Nitrogen is amine, but the nitrogen is directly attached to 3 carbon, making it a tertiary amine. Here benzene ring. And next is carbonyl with nitrogen. Carbonyl with nitrogen is a amide, but this amide is a part of the 6-membered ring. So I can say that it's a cyclic amide, and cyclic amide are lactams. Next, we have a molecule, progesterone, which is a steroidal molecule. Here, carbonyl group, both the sides single bonded carbon, so it's a ketone. Similarly, carbonyl, single bonded to carbon on both sides, ketone, and carbon-carbon double bond is alkene. This molecule is having many functional groups. I would suggest you to pause the video for a few minutes, circle the functional group and identify them by yourself. I have circled the functional group here. Let's try to find out each one of them. Carbon triple bonded to the nitrogen, so CN is nitrile. Carbon triple bonded to carbon is alkyne. Carbonyl group next to hydrogen. So when we have a carbonyl group and this carbonyl group is single bonded to hydrogen, then it's a aldehyde functional group. Here we have a 6-membered ring, benzene. Next, there is a carbonyl group and this carbonyl group is attached to oxygen. So yes, it's an ester, but the ester is a part of 6-membered ring. So we can also say it's a lactone. Next is OH. OH is alcohol, but carbon holding the OH is attached to 2 carbon. So this is an example of secondary alcohol. Carbonyl group next to OH is carboxylic acid. SH is thiol, because we know that OH is alcohol, which is represented by ol. So sulfur is thio group, thio plus ol, thiol. Carbon-carbon double bond is alkene. Carbonyl on both side carbon is ketone. Nitrogen is amine. Nitrogen directly attached to 3 carbon, making it tertiary amine. Then we have a carbon holding Cl, so it's an alkyl halide, but carbon holding Cl is attached to 1 carbon. His first neighbor is 1 carbon, so this is an example of primary alkyl halide. Thank you very much for watching this video. I hope this video helped you better understand functional groups and how to identify them in various compounds. If you found this useful, don't forget to like and subscribe for more chemistry content. If you have any questions or need further clarification, feel free to leave a comment below. Keep practicing and stay curious.